In the industrial world, distributing goods to various locations often present challenges. In terms of efficiency and cost, this is known as the transformation problem. In here we have a problem. There is tree factory that need lumber supply. Yellow factory need 500 ton. Orange factory needs 700 ton. Green factory needs 600 ton. And there are train, red, and green suppliers that can provide lumber to that 3 companies. Train supplier have infinity stock. Red supplier also have infinity stock. Green supplier have 500 ton stock. The train supplier transports lumber by train, which provides an unlimited delivery capacity. The following are the transportation costs from the train supplier to the 3 factories. To the yellow, orange, and green factory, $1,000, $3,000, and $5,000 respectively. The red supplier transports lumber by truck, which provides 200-ton delivery capacity. The following are the transportation costs from the red supplier to the 3 factories. To the yellow, orange, and green factory, $3,500, $4,000, and $4,800 respectively. The green supplier transports lumber by truck, which also provides 200-ton delivery capacity. The following are the transportation costs from the green supplier to the 3 factories. To the yellow, orange, and green factory, $3,500, $3,600, and $3,200 respectively.
Okay, so we can solve the problem on the previous videos or finding the minimal cost that the factory needs on the supplier by using the simplex method. So now let's X be the tons of lumber that the factory needed from the supplier, and X1 means from the train supplier into the yellow factory, and then X2 means from the train supplier into the orange factory. X3 means from the train supplier into the green factory, and the next X4 is mean from the red supplier into the yellow factory, and then X5 means from the red supplier into the orange factory. X6 means from the red supplier into the green factories, and then X7 means from the green supplier into the yellow factory. X8 means from the green supplier into the orange factory, and then X9 means from the green supplier into the green factory. And then from this notation, from this variable, we can see the notation.
So this is a mathematical model for the problem. In the simplex method, to find this minimized problem, we must find the maximum problem, and then we negating it. And the negation of the maximum of the solution, negation of the solution of maximum problem is a solution for this minimized problem. To change this minimized problem is by negating the objective function and all of the constraints. So this is a maximized mathematical model. In this mathematical model, we must find the solution and then negation the solution to find the minimized solution of the problem before. Next, to find this maximum problem, we must find firstly we must find the initial table. This is initial table from the problem. Firstly, we must take a look to the ZG min CG. If the ZJ min CJ is positive, so the table is optimum. And if it is negative, the table is not optimum, and then we must next to the next iteration. To next to the another iteration, we must find the row transformation of all row. To find the row transformation, we must find the k column and k row. K column is a smallest negative value of the Zj means Cj. In this table, it is a column 1. So column 1 is a k column. Next is a k row. To find the k row, we must find the ratio of the table. Ratio is a q column dividing by the k column. And then k row, yes, k row is a smallest positive number. This is, and in the table, smallest positive number is row 1. So row 1 is a k row. From k column and k row, we have one value that is in the k column and k row. This is cell 1, 1. Next step is find the row transformation. The first row transformation is a k row transformation. It means row transformation in the k row that we have. This is a row 1. To find the k row transformation, we must divide all of the cell in the row 1 by the k column in the first row. And then we get this value. And after that, we must find the another k row transformation, another row transformation. It is a row transformation in row 2, row 3, and so on, by the value minus the value minus the k column in the row times by k row transformation. And then we put all this value and then so on until last row. And next is another iteration. We must put the all, or we must substitute it to the another table, and then we get the another iteration.
Okay, so from the row transformation that we already get from the initial table, now we substitute it into the next table, which is this is the second iteration. Now look at the table and look at the Zg minus Cg row. On this row, this is shown that there still exists the negative value. So this is mean we still need another iteration, but we now need to find which one variable that will enter in the basis and which one the variable that will leave in the basis. So we can find it by looking the pivot from k column and row column. I mean k row. Okay, so first one, we will find the k column. Now look back at the Zj minus Cjk. We can see that the lowest value is located at the fourth column. So this is we call k column, and it also means that the x4 is the variable that will enter in the basis. Okay, so after that we will find the k row. Now we will find the k row by looking the ratio from the q column with the k column, which is the fourth column. So we will find the ratio by dividing the q column with the fourth column. And then we can see that from the ratio column, the lowest positive value is located at the second row. So this is mean the second row is the k row, and it is also indicate that the A2 is the variable that will live in the basis. So it basically means that the variable that will entering the basis is located at the k column, and the basis that we're leaving the basis is located at the k row. And after that we already find the pivot, which is located at the second row and the fourth column, and the value is 1. After we find the pivot, we will find the k row transformation from A2 into the x4 by dividing all of each values on this row with the pivot. And then here we have the k row transformation. Okay, after we find the k row transformation, now we're looking for another row transformation using the formula. So the formula is by subtracting all of the value on each row we subtract it with the values of the k column on each row that already times by the k row transformation, and then after that we got all of this in the row transformation. After that we will substitute it into the next column and the next iteration.
Yeah, after we input the previous calculation to the table, we get this third iteration table, and we will repeat the step. First, we will find the pivot, and to find the pivot, we need to know and find the k column and the k row. First, we will find the k column. To find the k column, we will comparing the Cj minus Cj. And the biggest negative, or in other words, the lowest number, the lowest value in Cj minus Cj that is negative is contained the k column. Our k column contains the lowest that number, that is minus m plus 1. And remember that m is very big, have very big values. And after that, we will find the k row. To find the k row, we need to calculate the ratio first. And the ratio is by divided. We will find the ratio by dividing the q column with the k column. And we get many undefined numbers, so we doesn't need to input it. And we get one biggest positive number, that is 500. And after we get it, we know that the row that contains this 500 and as the ratio is the k row. And after we get the k row and the k column, we know which one the pivot. Okay, we will get the pivot, and then we will do the row transformation. We do this row transformation, suppose the pivot to be 1 and the other value in the k column to be 0. Because the pivot is already 1, so we doesn't need to do any calculation in that row. And the other value have to be 0, but R4 and R7 is not 0 yet. They are 1. So we will do row transformation in the row 4 and the row 7. First, in the row 4, to make the row 4 to be to make the row 4 in the k column to be 0, we will use row 4 minus row 2. But we not do anything in the row 2. So the new row 2 is same with the row 2. So we just subtract row 4. Row 1. Row 4 minus row 1. And then we will calculate the value of the new row 7. The value of the new row 7 is by row 7 minus new row 2. The row 2 is same with the row 2, so it is the same with the table. So the row 7 minus row 2, we get it. Okay. After we get the new value, we will substitute the value to the next iteration table. Okay, and this is the fourth iteration table. And we know that the Cj minus Cj is already contain negative number. So that means we need to do iteration again, repeat the iteration, and we get the fifth iteration table and still contain negative number in Cj minus Cj. And this is the sixth iteration table, the seventh iteration table, the eighth iteration table, And then we contain, and this is the ninth iteration tabel. And finally, we found the last iteration tabel. Why we know that it is the last? Because the Cj minus Cj is already positive. We already get the optimal tabel, so we can calculate the optimal solution by sigma Cb times Q, that is minus 1 times 500 is negative 500, plus minus 4.8 times 200, and so on, and we get the value of maximum Z. But we need the value of the minimum Z, so we just need negativing the number. So the negative of negative 5,200 is 5,200. So we get the minimum cost, that is the supplier need to send to the factory is 5,200.
This is how the lowest cost scheme looks in this problem. To ensure the accuracy of our calculations and obtain an optimal solution, we used the POM-QM. The objective function and constraints were input based on the mathematical model. As shown in the image, the top row contains the coefficients for variables x1 to x9, followed by 12, and the solution row contains their optimal values. By inserting these values into the objective function and calculating 10 times 500 plus 30 times 700 plus 50 times 228 times 200 plus 32 times 200 and equal to 52,000. Thus, the minimum total cost obtained from the POM-QM calculation is 52,000.